right, so we're starting with, and you can see at the top here, a 45, 45, 90-degree triangle, and that's what we were doing. We had our square, and a square has equal sides. If they have equal sides, then therefore, if we split it, the angles too would be equivalent as we go through. Hence, that's what makes up the 45, 45. We started out with the square, split it in half, and then that created our 45, 45-degree triangle right there. So this is basically telling us what we just did. If our side length is x, we take that side length and multiply it by the square root of 2, and we automatically have our hypotenuse. So class, if this side length is 5, what's my hypotenuse? 5 root 2. If this side length is 10, what's my hypotenuse? 10 root 2. It could go on and on and on as we had just done. So let's real quick, let's look at the sine, cosine, and tangent. And I'm going to say right now that this is not, we're not going to go on into our homework with sine, cosine, and tangent, but that's leading us into stuff that we're going to be doing down the road when we get into the unit circle and that kind of stuff. So it's good to know as we move forward. So sine, according to SOHCAHTOA, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So if I have sine of 45, I want sine of 45, and I want to just represent that as a ratio, you know, comparison of the side lengths. Sine is opposite over hypotenuse. Does it matter which 45 that I use? No, it's going to be exactly the same. So opposite is x, hypotenuse is x times the square root of 2. If I have something in the numerator identical to the denominator, what happens to those? They cancel. Am I left with just 0? What am I left with? 1. Okay? So I have 1 on the numerator, root 2 on the denominator. So the sine of 45 is 1 over the square root of 2. Okay? Cosine is adjacent over hypotenuse. And again, it doesn't matter which 45 I use. It'll end up to be exactly the same since my side lengths and the angles are the same. So this is x, which is adjacent over hypotenuse. X divided by x times square root of 2. The x's cancel, and again, I'm left with 1 over square root of 2. A lot of times we try to not, and I don't mean that I'm trying to teach to the test by any means, shape, or form, because I never have a copy of it ahead of time, so that's kind of hard to do, but listening to my students after they take an ACT test or an SAT test and understanding the way in which the questions are worded, or sometimes more importantly, the way the answers are recorded. A few years back, you would never see a radical in the denominator because it's not politically correct. A radical, such as the square root of 2, is called an irrational number, and we don't leave irrational numbers in the denominator, okay? That just is just a mathematical statement that's happened for years. Up until recently, though, the students were coming back, Mrs. Meyer, there was a radical in the denominator. And so to get it out of the denominator, we did this crazy thing called rationalizing the denominator to get this out of there. We are no longer going to do that because our standardized tests are starting to represent it looking just like this. So we are going to leave the radical in the denominator, okay? That was probably more information than what you needed to know, but if somebody says, but you need to get that out of the denominator, or if in your class that you had last year or whatnot needed to do that, we are going to kind of change away from that and leave it in the denominator, okay, for that purpose. Okay, tangent is opposite over adjacent. Again, doesn't matter which we use, they're exactly the same. What is x divided by x? Anything divided by itself is 1, because they would cancel out. These are going to come back when we're doing a thing called a unit circle down the road, and we're going to be seeing these values over and over and over again. Very popular angle measurements that we're going to be looking at here, okay? All right, so let's look at exactly what we're going to be seeing on our homework for tonight. So we have a 45 degree triangle on A, B, C, and D. Sometimes the side is given, sometimes the hypotenuse is given, but we are told that we want to find the missing sides. So this is a right angle. The 45 is given. Don't ever assume. Okay, we can't assume. One of those angle measurements needs to be given. If this is 4, this is 45, what's this side length going to be? It's going to be 4. Because in a 45-45, both the sides are equivalent. It's called an equilateral triangle. So if I'm in a 45-45 90-degree triangle, the sides given, what's my hypotenuse? 4 times square root 2. Either one is good. Very good, Jacob Moore. You did a great job with that answer. Okay. 4 square root of 2. Okay. Yes, Ashton Irwin, you have a question for us?
Where'd you get the 2?
Right back up here. If you have a 45-45 90, you take the side, you multiply it by the square root of 2 to get your hypotenuse.
Okay.
Always. Okay? Now, what you cannot do, I don't like to be negative, but here's my negative. You cannot represent this as a decimal. That's why I said you really don't need a calculator today. 4 times the square root of 2 is perfect. It's perfect, okay? All right, let's look at B. I have a 45-45 90. Therefore, I know that these sides are the same. So if this is 3 times the square root of 2, what's this side going to be? 3 times the square root of 2. Now, even though this side looks a little crazier than just 4, don't skip this step. If you're like blanket, well, I don't know how to do this. Absolutely you do. We're going to take the side, because if you keep it in context, it's the side times what that gives us a hypotenuse in a 45-45 90. The side times, okay, so if this side is 3 root 2, this side is 3 root 2, what do I multiply this side by to get to my hypotenuse? Root 2. So I'm going to take this side times, and I don't care how crazy that side looks. How crazy the side looks, I'm taking that side times square root of 2 every single time. Now stay with me. If I have 2 radicals, again, we kind of reviewed this right before we started. If I have 2 radicals, square root of 2 times the square root of 2, what do I have?
3 root 4.
3 root 4. What is the square root of 4?
2.
And what is 3 times 2?
6.
So I actually end up with 6 as my answer. And you can take a second and look through that. Now, I might be throwing a lot of shortcuts at y'all at once, but some of you are going to be able to pick up on it pretty quickly. Others of you, at least put it in your notes so that you have it. We have square root of 2 times the square root of 2. You guys told me that was the square root of 4, correct? What is the square root of 4? 2. All right, I'm going to come up here. This has nothing to do with this problem. If I have the square root of 3 times the square root of 3, what is that? The square root of 9. What is the square root of 9?
3.
If I have the square root of 4 times the square root of 4, I get the square root of 16. What is the square root of 16?
4.
Does anybody see a shortcut? If I have the square root of 5 times the square root of 5, I get the square root of 25, which is 5. What am I ending up with here?
The number under the radical.
The number under the radical. So anytime that I take the square root of 2 times the square root of 2, your answer is just going to be 2. Okay? All right, let's look at C. I have an A for my side length and H for my hypotenuse. What does H equal?
45.
12.
Okay, this is 12. But wait a minute. What side is 12? This is my hypotenuse. Okay, stay with me. On A, we had the side. To get to the hypotenuse, we multiplied by the square root of 2. Thank you, Cameron. Now the hypotenuse is given, so I'm going to do the reverse. And instead of multiply, I'm going to divide by the square root of 2. The square root of 2 is sticking with you through 45, 45, 90s all the time. Now watch how easy this is. What's my hypotenuse?
12.
12, and what am I doing?
Dividing it by 2 should be 6.
So 12 divided by square root of 2. Does 12 have a radical with it? No. I leave my answer as it is. If 12 had a radical, then it'd be the square root of 12 over square root of 2, and then it would be 6, or square root of 6, but it doesn't. So it stays just like that. I cannot simplify it any further. What about A, or excuse me, this side over here?
It would still be 12 over.
Perfect. 12 over square root of 2. Okay? Now let's look at D. Now this picture, since it's on this worksheet, we can pretty much assume that it is a right triangle. And if you turn it, your paper a little bit, you can see it a little bit better. There's my right angle there. And directly across the right angle is always my hypotenuse. So if my hypotenuse is 5, from the hypotenuse to the side, I divide by the square root of 2. So this side becomes 5 over square root of 2. And if this side is 5 over square root of 2, what's this side? That's perfect. 5 over square root of 2.
Let's get that.
Okay? Up at this very top, you've got a little spot. That's perfect for another example. Oh, that's an awful perfect right triangle, but we're going to make it work. Okay, let's say I've got 5 root 3. And we're to find all the sides of the triangle. I have 5 root 3. What's this side going to be? 5 root 3. And I know given a side to get the hypotenuse, you multiply. From the side to the hypotenuse, you multiply. Because always remember, your hypotenuse is your longest side. So if I want to increase my length, multiplication makes sense. Okay, so if given a side to get to that hypotenuse, I'm going to multiply. So I get 5 root 3 times root 2. Those are the only two that can multiply. So I end up with 5
Root 6.
root 6. Okay?
That's it.
Questions? You're either multiplying by square root of 2 or dividing by square root of 2, all depending upon what's given first. Evan?
Is your thing still on?
Yep, you want me to turn it off?